Hey, what's up? Here we have a really long question because there are 4 equations and 4 unknowns. So we're gonna solve this system of equations. I'm gonna use a matrix because it's most compact to use a matrix. Kind of nice way to solve this. Now, since there's 4 equations and 4 unknowns, I'm gonna rewrite the matrix 4 times. So however many equations there are, you kind of want to have that many matrices, kind of a general rule. All right, let's start. So I'm gonna first take the coefficients. So for x1, the coefficients are what? Right there. So 1, -3, 2, and 0. And then I'm gonna move to the right, x2. I'm gonna take these coefficients, which are 3, 1, -4, and 2. Then I'll move over. What are these coefficients? They're kind of invisible. There's an invisible 1 right here. So it's x3 are what? -1, 1, -2, and 0. We like zeros. x4, take those coefficients, which are what? So let's put x4 here. So 2, 3, 1, and -4. Put a line here for these equal signs, and then these are going to be the constants. Okay, constants: -2, -5, 3, and -6. Okay, that's my first step. Okay, now what I want to do with these is make these numbers all zeros and then rewrite the matrix. Then I want to make all these zeros, move on to the second column, rewrite the matrix, and then make that a 0, because that might not be 0 anymore. And then rewrite the matrix. So I've written the matrix once, and this is my procedure. Do you see how I did that? You know, one thing that I'll make note of is that I'm trying to make all of these numbers 0. Okay, all of these numbers I want to be 0, because then it will be really easy to find x4 from there. And then once I know x4, I'll plug it in to find x3. And then once I know both of those, I'll plug those in to find x2. And then I'll find x1. And I'll just go up. We call that backwards substitution. Okay? So once again, make all of these zeros, then make these 0, then make this a 0 to get the upper triangular matrix. I'm actually going to follow a specific order. I want to get rid of this -3 first. That's first. Then I want to get rid of that 2. That's second. And then luckily this is already a 0, so we don't have to get rid of that. Otherwise this would be 3. So I'll start with that, and then I'll pause before I start moving on to these. Okay? And since I'm working on these 3 numbers, what's right above it? Think of like an eye. So I use this the dot of the eye to get rid of the body of the eye. Right? So then when I move on to this, I'm going to use this point to get rid of this body of the eye. And then this is like a short eye, so I'm going to use that point to get rid of that. Ha! Never thought of that. It's like a little eye, so you want to use the dot of the eye to get rid of the body of the eye. Okay. Think of new things every day. Alright. To get rid of this -3, I want the opposite of -3, which is +3. Therefore, I multiply this first row by +3. So 3. Now here you're going to have a lot of calculations, so be careful. Okay. Now I've multiplied 3, so I'm going to take this row here and put it right beneath it so that the 3 will cancel the -3. Alrighty, the 3 and the -3 are going to cancel, so I like using my orange pen. So 0, 10, -2, 9, -11. I'm going to call this my new second row. Call it 2 star. It's my new second row. So this is going to stay the same. That's going to stay same. And this is actually going to change, right? These are all going to change. These bottom three, they are all going to change. Because these bottom three are like the bottom part of the eye. But this dot, that doesn't change. It's the dot of the eye. Alright, got to get rid of 2. Multiply this by what? -2? Yep, -2. So we'll come up here. We'll put a -2 here. And we'll copy this. Copy these numbers. I guess I can take the whole thing and the arrow. What do we get? -2, be careful, -6. Alright, then I'm going to take this row that I'm trying to replace this 2. So I'm going to take that row, put it right beneath it. So 2, -4, -2, 1, and 3. Add these up, pull out my orange pen, cross these out, put a 0, -10, 0, -3, and 7. Call this 3 star. Alright, so we have finished. When I say 2 star, this is my new row 2, this is my new row 3. So that's 3 star. Remember I replaced the 2. Luckily there's a 0 here, so we don't need to do that one. It's already done. So now I'm going to rewrite the matrix. So watch how we do that. Let's see. Can do it here. Or maybe I'll move this. I lost my 2. My negative. I lost my negative. So my first row is staying the same. 1, 3, -1, 2, and -2. I got a new second row. 0, 10, -2, 9, -11. I got 0, -10, 0, -3, 7. My last row stayed the same. 0, 2, 0, -4, -6. Okay? So we're good. So now, what we're gonna do, so we're glad we finished this. This column looks good. We got the zeros that we want. Now we're gonna move on to the second column, but we're sort of going down in a triangle. So now we want these 2 numbers to be 0, and this is gonna be our dot, our pivot element. We're gonna use this 10 to eliminate this and this in the same way. So I'm gonna follow this order. I'm gonna first get rid of the -10, then I'm gonna get rid of the 2, and then see where I'm at. Maybe rewrite the matrix. So notice that now you can think of it that we now have like this 3x3 system, whereas before we had a 4x4, sort of reducing the matrix. So here we go. Now this is really good news that we have a 10 here and a -10, because I want to use this 10 to get rid of the -10. Remember, the 10 is my dot of the eye. So really, it's a nice dot because the 10 gets rid of the -10. So I just can add these together. So I can just really copy these for my work. Save me some effort. Maybe get rid of that. Pull this down. And I'm going to eliminate the 10 and the -10 because I'm just going to add these together. They're perfectly lined up. So 0, -2, 6, and -4. Now remember, these 2 are kind of done. They're done. Now this one is changing right now, so that's going to change, and this is going to change. So this is going to be my new 3. That's my 3 star, right? And now I got to get my 4 star. I got to get rid of that 2. Now how I get rid of that 2 is going to be a little bit tricky, because this is a 10 now. Usually this is kind of a 1, and if it was a 1, then we would just multiply this times, -2, because 1 and -2 gives you -2, and -2 plus 2 is 0. But I'm going to do something tricky here. Some people require the diagonal elements to be 1s, but I don't. I'm going to do something tricky here. what I'm gonna do is multiply this by -5, right? I'm gonna leave this as a 10, and I'm gonna multiply this 2 times -5, and I'm gonna save myself a lot of work. So let's try that. Let me just move this down like that and start here. So I'm gonna do -5 times 2, 0, -4, and -6. Try not to make a mistake here. So -10, 0, 20. What's 30? And I'll take the negative, and I'll take, okay, so I multiplied the -5 times everything. And now I want to, remember what I did? I multiplied the -5 times this bottom row, so I need to take this top row and put it right beneath it. So 10, -2, 9, and -11. These are gonna add. So I'm gonna get my orange pen, cancel those out. I'm gonna get a 0, -2, 29, and 19. Get some prime numbers here. Those never look good, but we'll see what happens. This is gonna become a 4-star. That's a 4-star equation because it has 2 prime numbers. No, I'm just kidding. So now that I've finished my eye, I've completed my eye here. I'm done with the second row, so I can rewrite the matrix. So let me do it. Let me do that. Let me rewrite this matrix. I'm gonna cheat a little bit by copying all this. Copy, paste, get rid of this. My new 3-star, I'm gonna put a 0 and 0 there because we didn't mess with those. We were in this bottom right corner. We were in this 3x3 right now. So I'm gonna put a 0. Ooh, these are all divisible by, these are all divisible. I'm gonna do something real quick. I'm gonna change this. I'm gonna divide this. I'm gonna divide by, I didn't realize that. I'm gonna divide by -2. Make this a 1, -3, and -2. Kind of like that. Simplify those numbers a little bit. So 0, 1, -3, -2, and then 0, -2, 29, and 19. From these numbers, my 4-star. All right, so I got 3 zeros here, 2 zeros here. Now all I need is 1 0 there, and I will have an upper triangular matrix, which we can use backwards substitution on. So to get rid of this -2, I need this to be a 2. See my little I here? This is my dot. I'm gonna use that 1 to get rid of that -2. So let's just be in like a little 2x2 system here. So let's say that we multiply this times 2, 1, -3. Oops, what happened to you? 1, -3, -2, 2, -6, -4. Right beneath that, we'll put this equation. So this is going to be -2, 29, 19. Get our orange pen, cross those out. Get 0, 23, and 20. Hold on. I think there's a mistake. 19. This must be positive. Because I really want that to be 23. Now, why would that be positive? Remember, I divided by -2, didn't I? So if we divide by -2, what's -4 divided by -2? We saw that -2 divided by -2 was 1, and then 6 divided by -2 was -3. That's correct. But -4 divided by -2 is +2. How come none of you guys told me? No, I'm just kidding. So that should be a 2. This should be a 2. +2. Where'd that go? Here? So that should be a +2. So this should be a +2. So this should be a +4. And voila, 23 and 23. 2 prime numbers back together, reunited once again. 2 prime numbers. All right. Whew, close call there. So let's see, I'm gonna copy this, paste, change these. We just eliminated these. And we got, by the way, I'm gonna simplify this and make it 0, 1, 1. So 0, 1, 1. Because you can always divide. That's one of the row operations. Divide by 23. You can divide an equation by a constant, right? It's like dividing both sides by 23. All right. What I'm gonna do now is rewrite the system of equations. x1 plus 3x2 minus x3 plus 2x4 equals to negative 2. 10x2 minus 2x3 plus 9x4 equals to negative 11. x3 minus 3x4 equals to 2. x4 equals to 1. Now that is an upper triangular system. Now these things are easy to solve because you already have x4. So then you plug the 1 into here and use substitution to find x3. So this is like smooth sailing for us. x3 minus 3 times 1 equals 2. Well, that means that x3 minus 3 equals 2, and that just means that x3 equals 5. Okay? So we got x4, we got x3. Now we'll move on to the second equation, because we're done now with the bottom and the bottom and second to the last. So we'll move to the second equation. 10x2 minus 2 times x3, which was 5, plus 9 times x4, which was 1, equals negative 11. That's 10x2 minus 10 plus 9 equals negative 11. That's 10x2 minus 1 equals negative 11. And that tells us, so long here, 10x2 equals 2. Negative 10. Ooh, how nice. x2 equals negative 1. Lucked out there. Got a nice little integer. We're getting good integers here. Good solutions. Last equation. Top equation now. Top equation. Gotta find x1. So what do we get? Do we have room to write it? Yeah, x1 plus 3 times x2. What was x2? Let's go faster on this one. x1 minus 3. Okay. Minus x3. What was x3? So minus 5. Let's see if we can go faster. Plus 2 times x4. That's plus 2. Equals negative 2. That's negative 8. And 2. That's negative 6. So x1 minus 6 equals negative 2. That means x1 equals to 4. If you add 6 to both sides. Okay. Whew, so much work. What was x1 and x2? 4 and negative 1. Let's see. Ooh, all the way up. 4 and negative 1. Okay. What were x3 and x4? Were they 5 and 1? Let's see. 5 and 1. Yep, 5 and 1. Looks like we got it correct. Whew, so much work, huh? How many pages did we do? 1, 2, 3 pages. 3 pages of work. So tough one, 4x4 system of equations. Hope that helps.